everyone, how are you? So today our lesson is about development of the modern periodic table. Our question today is how are elements organized in the periodic table? To know the answer of this question, let's start the lesson. We have some vocabs we will learn during this lesson. Periodic law, group, period, representative element, transition element, metals, alkali metals, alkaline earth metals, transition metal, inner transition metal, lanthanide series, actinide series, nonmetal, halogen, noble gas, and metallide. So as we know that atomic number is the number of protons in an atom. In the late 17th century, Antoine compiled a list of the 33 elements were known at that time, and he divided them into 4 groups: gases, metal, nonmetals, and earths. As you see on this table, the names of these elements are the old English names. So first, let's start by John Newlands. In 1864, English chemist John Newlands proposed an organizational scheme for the elements. He notes that when the elements were arranged by increasing atomic mass, their properties represented every eighth element. So he arranged the elements according to the increasing of the atomic mass. And he notes that the properties repeated every eighth element. A pattern such that is called periodic because it repeats in a specific manner. So, as the properties of the elements they are repeating each eighth element, the same properties are repeating. So this pattern is called periodic because it repeats in a specific manner. So Newlands named the periodic relationship that he observed in chemical properties the law of octaves. So he named this relationship as the law of octaves because after the musical octaves in which notes repeat every eighth tone. So as the musical octave, there is repeating in every eighth tone, so that the elements repeat their properties each eighth elements. That's why he called this properties as the law of octaves. So as you show on this figure 1 shows how Newlands organized 14 of the elements which they were known in that time. Acceptance of the law of octaves, as we said that he called this law as law of octaves, was hampered because the law did not work for all the known elements, but this law was hampered. Why? Because the law did not work for all the known elements. Also, the use of the word octave was harshly criticized by the scientists because they thought that the musical analogy was unscientific. So they rejected this law, which is the law of octaves, because as we said that this law did not work for all elements were known at that time, and also the word octave was according to the scientists was unscientific. So while his law was not generally accepted, but Newlands was basically correct because the properties for elements do repeat themselves in a periodic way. Okay, so again, many new elements were discovered during the 1800s. Scientists needed a better way to organize knowledge about the element. So John Newlands, so he is the first scientist who proposed an arrangement for the element, and he arranged them by the increasing of atomic mass, and he also notes that properties repeated after every 8 elements, and he called this law as what? As octave law. Now, after Now, after John Newlands, we have Mayer and Mendeleev. So, in 1869, German chemist Mayer and Russian chemist Mendeleev each demonstrated a connection between atomic mass and the properties of elements. So, they proposed a connection between atomic mass and the properties of elements. So Mendeleev, however, is generally given more credit than Mayer because he published his organizational scheme first. Like in Newlands, several years earlier, Mendeleev notes that when the elements were ordered by increasing in atomic mass, there was a periodic pattern in the properties. So Mendeleev, he notes that as in Newlands, that there were a pattern in properties of the elements when we arranging them according to the increasing of the atomic mass. By arranging the elements in order of increasing atomic mass into columns with similar properties, Mendeleev organized the elements into a periodic table. So the first one who organized the element into a periodic table is Mendeleev. He arranged the elements in order of what? Of increasing the atomic mass. So, this is the Mendeleev table shown in figure 2, this figure, because widely accepted, because his table became widely accepted because he predicted that the existence and properties of undiscovered atoms that were later found. So, Mendeleev left blank spaces in the table where he thought the undiscovered elements should go. By not trends in the period properties of known elements, he was able to predict the properties of the yet to be discovered elements. So, Mendeleev, he was the first scientist who arranged the elements in a periodic table according to the increasing of the atomic number, and he left blank spaces in his table because he thought there were undiscovered elements should be in these spaces. Okay, so this figure in the first version of his table published in 1869, Mendeleev arranged elements with similar chemical properties horizontally, and he left empty spaces. As you see here, we have empty spaces. These empty spaces for elements that were not yet discovered. Okay, so again, Mendeleev made a table arranging the elements in order of atomic mass into columns with similar properties, and the empty spaces in the table enabled him to predict the existence of undiscovered elements.